Welcome to section 4.2 of geometry. We're going to talk about congruent figures. What are they? What are some of their characteristics, and how can we know if figures are congruent, and how can we prove that they're congruent? So that's coming up. We have two types of figures to begin with. If I have a circle, how do I know if two circles are congruent? If I just compare the radius of one with the radius of the other. If the two radii are congruent to each other, then the entire circle is the exact same size. Remember, congruent means it's the same size and the same shape. So it's a copy and paste thing on a computer. If I can copy it and paste it and lay one right exactly on top of the other so it just totally everything matches up, then it is congruent. And if the two radii are the same in a circle, then they're the exact same size. And circles obviously have the same shape. So in order for the polygons to be congruent, every corresponding side is congruent and every corresponding angle is congruent. Again, I would be able to map one, drag it over, and put it right on top of the other. It would line up perfectly. That would make it congruent. So to tell, I have to check, are all the corresponding angles the same? Are all the corresponding sides the same? Let's take a minute and talk specifically about triangles. If one triangle is congruent to the other. So triangles are congruent if, and only if, all the angles, corresponding angles are congruent and all the corresponding sides are congruent. This is a congruent statement. The symbol means triangle. So this says triangle ABC is congruent to triangle DEF. I'm not even going to draw a picture. I'm just going to tell you how important this statement is. When you write a congruent statement, corresponding angles are written in corresponding order. So if these two are congruent, then all corresponding angles are the same. Angle A has to be congruent with angle D. Angle B has to be congruent with angle E, and angle C has to be congruent with angle F. This is how you could list them. Angle A is congruent to angle D. Oh, that's my symbol for angle, remember. Notice they're in corresponding positions, so I know that has to be true. I can do the same thing with the sides. Side AB corresponds to side DE. They have to be exactly the same length. They have to be congruent, so I can also make congruent statements about the three sides. AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. So those are my three statements regarding the sides. Notice I didn't even have to see the two triangles to know what corresponds with what because of the congruent statement. That means when you are asked to write a congruent statement, make sure that you put corresponding angles in corresponding order. Now there's a shorthand way to acknowledge that all the corresponding parts of congruent triangles are congruent. If the triangles are congruent, then all their corresponding parts are congruent, which we just listed on the board. So we can abbreviate that to CPCTC. That's shorthand for corresponding parts of congruent triangles are congruent. Okay, here's my attempt to draw a scissors truss, and we all know by now that I'm not a great artist, but that's okay. Hopefully this sketch gives you a good idea of what we're dealing with. This would be a scissors truss used in building roofs, and we have some congruent triangles. So first I'm going to start with my congruent statement. Triangle UVW would be congruent to triangle, and I want to make sure I do it in corresponding order. I'm going to say YXW. So if you get a problem like this, you have a diagram, you have a congruent statement, and you are asked to list all the parts, then you would do just what I did with triangle ABC and triangle DEF. So I took the time to list them just like I did on the others, except now we have a diagram that goes with it. Notice they're not laid next to each other in the exact same way, so you have to be careful. It's not UVW WXY, it's UVW YXW, right? So here's my angles, and here's my sides. Okay, here's an example of a kind of problem that you can be given with congruent figures. I'm asked to find the measure of angle X if the measure of angle U is 22 and the measure of angle UWV is 30. Let me put the information that I've been given into the diagram. U is 22 and angle UWV is 30. And I'm asked to find angle X. Notice these two angles don't have anything to do with angle X. They're in completely different triangles. But that doesn't matter because I already know, this is assuming, that these triangles are congruent. So if they're congruent, then angle X and angle V would have to have the exact same measure. And since I have 2 out of my 3 angles in that triangle, I can find the measure of angle V and know it'll be exactly the same as the measure of angle X. So 22 plus 30 plus angle V, the measure of angle V, equals 180, and I solve for the measure of angle V. So when I subtract 22 and 30 from 180, I realize that the measure of angle V has to be 128 degrees. How do I know that that means angle X is 128 degrees? Because corresponding parts of congruent triangles are congruent. And since those two correspond, angle X is 128 degrees. Okay, now what we're going to do is we're going to walk through step by step how to prove that 2 triangles are congruent. Remember, triangles have 3 sides and 3 angles. So in order to prove that they're congruent, I need all 3 sides and all 3 angles. That's 6 different congruent statements in order to prove that 2 triangles are congruent. Later on, we're going to learn how to do it more simply so that we don't have to say all 6. But for now, we need all the corresponding parts. So the first step, remember, to every proof is to list what you are given. We are told that BD and CE bisect each other. And if you look at the diagram, you can also use the given in the diagram. Angle B is congruent to angle D, and DE is congruent to BC. So I'm going to write all that given first. So here's step 1 of my 2-column proof. I've listed my angles, the sides that were given in the diagram, and my given statement about BD and CE, those segments bisecting each other, and said that that's given. Now, what do I know because of this? I know because if BD and CE bisect each other, then that means this point right here, point A, has to be exactly in the middle, because that's what a bisector does. It cuts something exactly in half. So point A must be the midpoint. So I'll make that my next statement. Okay, so I've written down that A is the midpoint of BD and CE because, how do I know that? That's the definition of a segment bisector, which is what I got in my given. Now, why is it important that A is the midpoint? What do midpoints do? Right? They divide segments exactly in half. If that's the case, then what do I know about EA and CA, right? And what do I know about BA and DA if that A cuts it exactly in half? That's going to be my next statement. Okay, I've listed my congruent segments based on the fact that A is the midpoint. If A is the midpoint, then AC and AE are congruent. that's because of the definition of a midpoint. That's what a midpoint does. Notice I have now 1, 2, 3, all 3 of my sides. So now all I need are my angles. And I was given B and D. I need my 2 other angles. So looking at the diagram, do you see any other angles that you know are congruent? Hopefully you see these 2 angles are vertical angles, and we've already learned vertical angles are congruent, so I'm going to list that next. Okay, I've listed my 2 vertical angles, angle BAC and angle DAE, and my reasoning is the vertical angles theorem that we learned earlier. Now I have this angle and this angle. If you want, feel free to mark your diagram. All I need is angle C and angle E. How do I get those? Remember, if I have 2 angles, then do I automatically have the third? Didn't we learn that previously? So I should be able to state my third angle next. Okay, angle C is congruent to angle E, and I just wrote that shorthand formula yesterday. If I have 2 angles, then that implies I have all 3 angles. That's enough. 2 angles ensure that's the third angles theorem. Now, look, do I have 1, 2, 3 sides and 1, 2, 3 angles? I do. I have all my sides and all my angles, so now I can write my statement that triangle ABC is congruent to triangle ADE. What's my reasoning? Okay, how do I know that triangle ABC is congruent to ADE? Because by definition, if all 3 sides and all 3 angles are congruent, then the triangles are congruent. So that's just definition of congruent triangles. And yes, I did symbols as a shorthand, but it works. It communicates my reasoning. So I have now totally proven that these 2 triangles are congruent. Okay, the properties that we looked at earlier, the reflexive property, the symmetric property, and the transitive property, it works with segments, it works with angles, it also works with figures. So if I can say these 2 triangles are congruent, then I can use one is congruent to the other. That's the reflexive property. I can use the symmetrical property, and I can also use the transitive property as well with figures, just like I did with segments and with angles. So that those properties follow through, and these congruents are also an equivalence relation. So if the figures are congruent, then their corresponding parts, the lengths are equal. They have equal measures. So that's also true in congruent figures. What I want to do now is I want to work through some problems, some ramifications of this, and I'm going to let you pause it and try to answer it. Then I'm going to show you the correct answer. That should really help you with the work you need to do. Okay, here's a figure, a rough sketch of 2 triangles with some incomplete congruent statements. You would need to complete these. So pause the video if you need to, come up with what you think the answers are, then restart it, and I will show them to you and see if you got them right. So go ahead and pause. Okay, the first one is angle RAT. The next one is angle R. The next one is angle RTA. The next one is AR. The next one is itself. That one was tricky. That's reflexive property, right? Because TA is in both triangles. That's why you need the reflexive property, because you had to have that third side. And then MT is congruent to RT. How did you do? Here's another one for you to practice on. Again, it's a rough sketch. These triangles don't look congruent, but look at the markings. Notice these two correspond, these two correspond, these two correspond, corresponding angles. So these triangles are congruent to each other. What I've done is I've started 4 different congruent statements. I got the first half. I want you to write the second half, remembering that congruent parts have to be listed in corresponding order. So make sure you fill these out correctly. This is really, really important to be able to do this right. A lot of students miss this, so make sure you've got it. Pause the video, decide how to finish each one of these congruent statements, and then I'll show you what the correct answers are. Okay, for the first one, triangle RTS would be congruent to triangle KMP, corresponding order. Triangle RST would be congruent to KPM, same order. Triangle STR would be congruent to triangle PMK, corresponding parts in corresponding order. Triangle TRS would be congruent to triangle MKP, This was somewhat simple to do because the triangles were laid out side by side so that corresponding parts were in corresponding positions. So then all I had to do was just match them up. In some diagrams, they can be reflected, they can be turned, they can really mess with you a little bit. So if you need to, if this is tricky, feel free to take whatever it is in the diagram and redraw them so that they are like this, and then that makes coming up with these statements a lot easier. Here's a different kind of problem. I am told these two triangles, triangle ABC, is congruent to triangle XYZ, and if the measure of angle B is 2x plus 15, and the measure of angle Y is 5x minus 12, can I solve for x? So see if you can figure out how to do that. Pause the video, solve for x, and see how you did. Okay, hopefully you paused and you tried it. If we're talking about angle B and angle Y, notice those are both the middle angles. They correspond, therefore their measures are equal. Because of that, 2x plus 15 has to be exactly the same as 5x minus 12. That's the secret for solving this. So when you put your x's together and your numbers together, you've got 3x equals 27, so x is equal to 9. How did you do? Here's another problem from the same triangle congruence. Side AC, the length of AC, notice it's not the segment, but the length of side AC is equal to y plus 25, and the length of XZ is equal to 2y plus 8. Knowing that, can you solve for y? Pause. Okay, hopefully you looked at your statement and saw AC and XZ correspond. That means their lengths are equal. So y plus 25 has to be exactly the same as 2y plus 8, which means y, when I subtract from both sides, y equals 17. Okay, so that's what section 4.2 is all about. Hopefully it made sense to you and you're ready to tackle congruent triangles. The only part that can be challenging, I know, is proofs. They always are, but I have confidence in you guys. I will see you again next time if you come back in section 4.3.